Hello guys, welcome to Insight Electronics. So my regular viewers know that I love repairing LED bulbs, and I have already published a lot of videos related to repairing LED bulbs with different complexities. So this time it's yet another one. This time it's made by Wipro. The model is Tejas. It's a 9 watt LED bulb, 6500 Kelvin, color temperature is cool white, 50 milliamps of current, 20 to 240 volts, and power factor greater than 0.9. So it uses an active power factor correction IC inside. These kind of things are really cheap nowadays, so most of the people are actually not trying to repair these things. When it gets damaged, they will give it to a local shop. If they say that okay, the repairing price is somewhat near to the price of a new bulb, they will just end up in the trash. But it's really easy to fix most of the LED bulbs. So let's see what is the problem with this one. So let me bring in the isolation transformer. This is a 30 watt isolation transformer, custom made, and the bulb is actually much close to here. Let me just turn this one on, and you can see pretty much nothing is happening. Let me just turn off this light, and you can see a slight flickering action going on like that. So let me take away this top cover. So this is the issue. It's kind of like acting in a weird way. So let's see how we can fix it. I hope you can see it properly right now. It's trying to start, but it won't. So that is the problem with this one. So let's keep the isolation transformer to the side. Let me turn on the main light, and we need to discharge this 2 pins first because it may hold a charge. Nope, not right now. If you are trying to repair LED bulbs which has been just plugged out, or like I did while testing whether it's working or not, and if it is open, it's before touching the main board, it's always recommended to discharge these two terminals, because there 100% of time there will be an output capacitor in here, and most of the time these are not isolated from the mains. These will be simple buck converters, so you will get a nasty shock either from the output capacitors or from the input capacitors as well, because these LED bulbs are not the regular 3 volt LED bulbs. These are either 6 volt or 9 volt LED bulbs in like 3 in 1 package. So the voltage at these 2 points will be around 100-150 volts depending on the wattage of the bulb. So always be careful. And you can see I have already opened the aluminum casing as well. So most of the time when you're trying to take it apart, it will be damaged for sure, because these things are glued shut really hard. These are not supposed to be taken out any other way. You can see the amount of glue that they are using in here and in here as well. I hope everything is in focus. So let's take this thing apart. So the reason why this aluminum casing has been taken out already is because I just wanted to make sure that nothing has been physically damaged inside, so like a capacitor or something. So inside, if you look, you can see there is no obvious signs of damage. The capacitor is alright. There are no bulged caps anywhere to be found, and there are no smoked or discolored part or anything. The color difference that you see is from the flex that they have used. So I have measured the voltage at this point. Since there is no obvious signs of damage inside, I just measured the voltage, and it is around 150 or something volts. Let me just show you that. Let me bring in the multimeter. So let's connect it in here, plus and minus, and let me turn it on. You can see the capacitor still had a charge in it, so it's on right now, and you can see the voltage is around 190 somewhat, rising 130 volts or something like that. So that is the reason why I said do not touch it with your bare hands, because most of the time you may get a shock if you are not careful enough. Okay, so now that we have seen that there is a voltage coming at these 2 pins, that indicates there is no problem with the driver circuit. If the driver was faulty, you would either see a lower voltage or no voltage at all. So now, since the driver is active, we can now start checking the LEDs. So for that, let me bring the second probe, the LED tester, which is now connected to the isolation transformer over here, and the LED tester is over here. It is now in the low voltage mode. I said in one of my previous videos that I will make a dedicated video for this LED tester if you guys are interested.
So now it is in the low voltage mode. So let's go through each LEDs one by one, and you can see that one is lighting up. This one is also lighting up. This one is lighting up. This one also fine. Seems like all the LEDs are fine in this case. Up to here you can see everything is lighting up perfectly. So if negative goes here, positive comes here. You can see these LEDs are all lighting up just fine. So let's connect. This LED is not lighting up. Why it is not lighting up? So it looks like this LED, okay, that LED is also fine, but
since all the LEDs themselves are fine, I am going to assume that there is like a dry solder somewhere. So that is the reason why sometimes this kind of issues will happen, and it's very difficult to give it a proper reflow because of this high heatsink below it. The soldering at the typical 25 watts or the SMD 15 watt SMD adjustable temperature iron is not going to cut it because of this massive heatsink area below it. So anyway, let me just give it a try and I shall come back after that. So guys, upon closer inspection I came to notice that this particular LED, this one LED over here, was not lighting up always. It lights up on its own, but when connected in circuit, when measuring in series with other bulbs, it is not lighting up. So as I said, because of this heatsink underneath, it is not easy to get a soldering on that, and for that purpose of giving it a proper solder, I in fact ended up damaging the LED. So now I have to short this particular LED with a piece of wire from one of these resistors maybe. So that is what I'm going to do now. Alright, I shall solder that and I shall come back after that. Alright, so now that I have made the solder joint, you can see it over there, this one. So let's see whether it works or not right now. So I'm going to plug it in, and immediately it has lit up perfectly. It just completely fills the camera, but in fact that was the problem with this LED bulb. So that is how you can fix an LED bulb if it was not working perfectly fine like you expected. So before bringing these kind of dead LED bulbs to the electronic repair shop and paying a price for getting it repaired, sometimes all it takes will be a piece of wire like that to do the trick. So yeah, I thought this information is worth sharing because there are a lot of people, especially the people, old aged people, they don't usually care about getting it repaired. But if they know, like, I'm not saying that everyone must have some kind of electronic DIY kind of mentality, but still, it's all about kind of like what. Anyway, forget about all those things. Like, if you can do it as a DIY kind of thing, it's better. That's what all I was trying to say. So yeah, I think that is enough for a repair video. Now you can just hold it, click everything back into the socket like how it is actually supposed to be inside, and we can call it as a day. And you need to make sure that this is now closed properly, because otherwise this round thing is actually connected to a metal heatsink around the whole casing. That is what keeps this thing cool. And if you insert it in a bad way, it's going to affect the performance of the bulb in the longer run. Effectively, it's going to kill the bulb in the longer run. So that is now fixed. And yep, thanks for watching. See you in another video.